So this video is on the 4.6 Green Worksheet number 5. We're going to work through getting y by itself. That's what they mean by solving each equation for y. Now in the first one, we have y being divided by 2 equaling the absolute value of x over 4. To get y by itself, you always want to do the opposite of what's currently happening to it. What I mean by that, it's currently being divided by 2. So we want to do the opposite and multiply both sides by 2. And what happens is the 2 cancels the 2, and you have y by itself. On the right, you have 2 times the absolute value of x over 4. And we'll leave it like that, and we'll analyze it later once you understand what dilations do, or how dilations work. We'll come back to this and analyze what happens to our absolute value graph, which normally looks like this, when it's being multiplied by one number and divided by another. We'll revisit that later. Let's just move over to B, and again, try to get y by itself. Name 2 things that are currently happening to this y. The students say it's being subtracted by 3 and divided by 2. So we need to think about the order of operations and reverse them. If you knew what y was, since it's all in the top, you would take away 3 first and then divide by 2. We want to undo that in the reverse order. So first we're going to multiply by 2. That'll get rid of the dividing. Next line will say y minus 3 equals 2 times x plus 1 squared. Then you'll get rid of the minus 3 by doing what to both sides? Adding 3 to both sides. So we could maybe call this getting the equations ready to put into the calculator. Otherwise, you wouldn't have been able to plug that in because we only have a y equals button. We don't have a y minus 3 over 2 equals button on our calculator. We must get y by itself so that we can plug it in. And what we'll analyze here is the normal parabola, x squared, is being transformed. I think you know 2 of the transformations. What does this do to it? Slides it left 1. What does this do to it? Slides it up 3. But we haven't really done a formal discussion of what this does. Not sure how your studies are going on your own, but it makes the parabola skinnier and taller by a factor of 2. We'll revisit that as well. Let's try part C on your own. Everybody do part C. I'm going to pause and the video if you're working at home should be paused and then unpause it. Now that you've unpaused the video, you can see the solution here is negative 3 times the square root of x plus 2, take away 1. Again, the negative 1 cannot go in and subtract here. You do not want to make this go in and combine like terms because they're not like terms. The 2 is being square rooted. The 1 is not. It makes them not like terms. If we were to analyze this graph, there are 4 things that would happen to it. The parent function's square root of x. Somebody name 1 thing that happens to it. Down 1 because of this. Another thing. It moves left. Left 2 because of that. Skinnier and taller. Very good. Because of this 3 out here, it actually gets 3 times as tall. Because the y's get multiplied by 3. More on that as you work through that on your own. So it's called dilated vertically times 3. That's what happens because of that 3. And there's one other thing. It does get flipped because of this negative sign. Because of this negative sign, it gets flipped downward. So your final graph would be flipped downward, but then shifted left 2, down 1. So if you were to graph that on your calculator, you should see something like this. Okay?